Hey folks, we're going to have another streamed out interview from our Exploit Hall of Fame series. This one's a new one you haven't seen. We originally recorded this one with Thomas Dullien, aka Halvar, just before the Pwn to Own competition, and during that competition his mother went into ICU, and we thought we'd give him a little bit of space. My heart to you goes out, sir. Yeah, it's hard. In any case, he has some brilliant insights and a little bit of history of the world of exploits for us here in the next stream. A quick little reminder to folks that we have November registration rates for CanSecWest available for 2 more days. The call for papers for our hybrid conference on March 16th to 18th next year is still open, and you can find all that stuff at secwest.net, where you can also find registration for our lightning talks next week that we're going to be holding in our online GatherTown space. Free for presenters. Come present 3 to 5 minutes and something, and come see your peers present that, or come chat with them in our positional environment there. Or for $14 to offset our bandwidth costs, you can just get a submission and lurk around and listen if you would like. Anyway, it's our new experiment about experimentation for online gatherings. So but without further ado, let's listen to some of the brilliant workings of Thomas's mind in this next interview. Good morning or afternoon, I guess, for you. Hi, folks. This is the second video of this Exploit Hall of Fame series, and I'm here with Thomas Dullien, colloquially known to everybody pretty much as Halvar, who is going to tell us about his long history of providing providing us technology and information about vulnerabilities. So, good morning. Hi, how are you?
Hey, Drag, it's nice to be here, and I'm doing okay, I think.
Let me shuffle things around here a little bit and make you the centerpiece. So, how's the lockdown has been? How's it been treating you? You've been juggling so many things lately.
Yeah, it's been a complicated 2 years, I reckon. Small kids, small startup, just lots of stuff. I could use a long vacation, but that's how it goes.
So I actually thought you were going for a long vacation when you left Google, but I guess you were being pretty busy. I don't know how much you want to tell us about that sort of stuff, but let's rewind the clock way back when to one of the tools that I think everybody watching this is probably going to be watching. So I'm going to ask you. Tell me a little bit about how you got into all this, and what's been the long and winding path to where we are today.
Yeah, I mean, it's been largely an accident in some sense. So when I was 8 or 9, I asked my older brother, how do you crack a copy protection? And my older brother replied, it's very easy, you just invert a jump. And I had no idea what a jump was. And then a couple of years later, I found myself going to high school in the US, in rural Minnesota, of all places. And I had the need to crack a copy protection, and that then made me find out what a jump is. I went to Barnes & Noble, which was a bookstore at some point in time, and then a book called Masterclass Assembly Language, and I knew that the jump had something to do with assembly, and I need to learn assembly. So I bought Masterclass Assembly Language, which was a book by a few Russian authors that walked you through writing a DPMI extender and putting the CPU into protected mode and all of this. So essentially a mini operating system in assembly. And that was a very good book. And then I started inverting jumps and removing copy protections. And that then ate the next couple of years of my life until I graduated from high school. And about a year before I graduated from high school, I realized, or perhaps 1.5 years, I realized that if you can do reverse engineering, you can also do security auditing. And at the time, the majority of people were doing source code auditing. And I realized, hey, if they're doing source code auditing, I may as well do binary auditing. So I started doing binary auditing, reverse engineering stuff, finding vulnerabilities, and then writing exploits for them. yeah, and one thing led to another, and the result was that on the day I graduated from high school, I boarded a flight to Asia and then worked for a pen testing company in Asia in 2000, and kept on writing exploits, and then moved into giving trainings classes about writing exploits later on. And then in 2003-ish, there was a Polish hacking group called LSD who had a whole bunch of good vulnerabilities in Microsoft products. And Microsoft was publishing patches, but no details about the vulnerabilities, and I found that very frustrating. So I built a prototype of what later became BinDiff, which became a tool to do patch analysis. And things went from there.
I think it was about, I'm trying to remember when I first met you. It was around 2004.
Must have been 2002 or 3. CanSecWest.
It was right around the time. So I guess walk us through. I'm going to ask you a couple of things. First of all, I'm going to ask you, what was the game that inspired that need to crack it? Do you remember? What was that? What was that first game?
Turns out it wasn't a game. It was so my original plan prior to learning reverse engineering and getting derailed was becoming a character animator for hand-drawn or computer animation. So the software I was trying to crack at the time was a software called QuakeMe, which was a Quake model editor for editing Quake models. And it had a limitation of only being able to save a certain complexity of model and a certain number of frames, and that clearly needed to go.
Okay, cool. So then, as I said, I'm going to ask you a couple things. One, I was going to ask you, you've looked at a lot of vulnerability areas, and you've got your own approaches to this sort of stuff, as well as a really long list of research that you've published. Let me ask you a two-part question. Tell us a little bit about some of the areas that you've looked at for vulnerabilities, and of the ones of the research you've done in the past and other things you've done. Which ones do you feel particular moving the needle and a sense of pride on, other than your kid? Because everybody should feel pride about having kids. So, but tell us on the tech side.
So on the vulnerability side, I think the first part of my career was mostly focused on closed source server-side bugs, because at the time in the early 2000s, the idea of a client-side bug was considered a little bit like unmanly, it was just something that you didn't do. So there was focus on back in the days, CNN.com was running on a closed source web server. If anybody remembers Netscape Enterprise web server. So you had a lot of strange closed source running everywhere, and Netscape Enterprise being one thing. It got rebranded into iPlanet web server after Netscape sold their server business to Sun. And then you had Domino running everywhere as a mail agent, like mail server. You had a lot of strange mail transfer agents, particularly in the Windows world. Then, of course, all of Windows.
And in those days, everybody was like, oh, even open source was still a dodgy concept. You had to pay for closed source if you wanted the good stuff. So that was the obvious target. Yeah.
Just getting the binaries for a lot of the interesting things was difficult. Like I remember trying to organize myself the executable files for Checkpoint Firewall and Checkpoint's VPN. So initially, most of my work was on closed source Windows binaries, and then from that I branched off and I ended up doing some reverse engineering on Cisco PICs in the early 2000s. Had very, very, very amusing, beautifully amusing bugs in their IPsec IKE stack at the time. So
it was a rich target environment.
Yeah, and I had a multi-year love affair with Ike as a protocol and ISA KMP and VPN protocols in general. And then my approach to vulnerability discovery changed a little bit from the moment that BinDiff came around, because once I had BinDiff, there was a time where you could just turn around exploits quickly enough. So the vendor would issue a patch, you would just diff it the same day. And then you try to generate an exploit faster than people could patch. Or you could move over to do variant analysis, where you would analyze a patch, and they would almost always screw something up, and then you would find variants of the same bug. And And also because BinDiff enabled me to pull symbols from things for which I had source into binaries, it opened up a lot of attack surface where third-party libraries were embedded inside an executable. So early days, a lot of Windows work, then a little bit of embedded work for stuff like PIX and similar embedded firewall networking gear. Then a long period of doing a lot of patch diffing. And then and different approaches to pulling symbolic information into binaries and so forth. I accidentally started a company with BinDiff, so I got into the situation that people wanted to buy BinDiff, but nobody wants to buy from a random student, and they wanted to have source code, escrow, and whatnot. So I created a small company that then started selling BinDiff, and then we built a follow-up IDE, like a reverse engineering IDE called BinNavi for a while. That was very, very useful because it was one of the first tools that integrated differential debugging, like recording execution traces and then doing set operations on execution traces with the rest of the reverse engineering process, and it was very, very useful. Did some work on NetScreen VPN devices during that period as well, because we got the GDB protocol spoken, and then we could reverse engineer NetScreen devices. That was fun. And
just as a comment. So sorry to say, it was both those tools. Before we were all stuck diffing hex dumps and trying to match all the. It was for the viewers, you single-handedly sort of made a quantum leap possible in all our productions for anyone who's doing analysis of this stuff. So it was a very very big move for everybody else, and that led. Tell us a little bit more about the history of the company, because that led you into a whole different sets of worlds, right?
Yeah. So I'm to this day I'm pretty proud of both, like all the products we built, like BinDiff and BinNavi. Like the fact that people are still using BinDiff now, even though it hasn't seen any algorithmic improvement or any real improvement since 2009 or 2010. That's something that kind of blows my mind, because I had expected it to be replaced with better tools quickly. And even like BinNavi is now defunct. It's open source, but it's hard to even get to build and so forth. But it's still the prettiest UI I've ever used for doing reverse engineering, and that's 10 years on, right? So we did get in some bizarre sense, I get prouder of the tools the further they receded into the distance, because they're not surpassed as much as you expect from the time delta. And with regards to the company, so the company was interesting because it was the antithesis of what you should do when you start a company. Like, I had no idea about the market size. It was a terrible market to be in, particularly if you're not US based and don't have cleared personnel, because as a bunch of
much of that business is in that world. Yeah.
So in some sense, we were selling reverse engineering tools to both offensive and defensive players, and we had a very interesting customer list. But also, we were always the untrusted foreigners for each one of our customers, and that led to a lot of really interesting interactions in customer support, where you've got a customer that's like, "Hey, how does BinDiff work on architectures you don't support?" And we're like, "Well, we don't know, but what architecture do you want us to support?" And they're like,
"We can't tell you."
Okay, can you give us a list of 10 architectures to support? We'll support all of them, and one of them is the one you want. Nope. Or random secret services calling you on the phone, asking whether they can drop by the office, buy software, and pay in cash. So it's a
colorful environment.
Most definitely. And then there was always the looming threat where a lot of our business was in the English-speaking world, but people from all over the world would be ordering our tools. And then there was the implicit threat of, hey, we can't tell you whom to sell to and whom not to sell to, but your selling decisions affect our buying decisions. And then you try to ask people, okay, so who can I not sell to, or who should I not sell to? And they're like, we can't tell you.
Yeah.
So, was a fascinating world. At some point, we considered getting external investment, like a venture capital fund or whatever, and then we tried to build a business plan and a pitch deck, and we realized the pitch is essentially, we're going to solve a whole bunch of really difficult computer science problems, and then we're going to sell that to 300 people worldwide at $800 a pop. So that,
yeah. Thank you for calling. See you later. Yeah.
So where the entire thing turned out to be a little bit of a success, though, is we realized that the algorithms we're using for BinDiff can be usefully used for doing malware analysis and classification, and also for automatically generating antivirus signatures. So we built something called the X class, which was essentially an antivirus lab in a box. You threw a bunch of malware in. It would use BinDiff-style algorithms to correlate them, group them into families, and then to automatically extract stable signatures that would catch the entire family from it. And then we try to sell that to the antivirus industry, and they're like, what is this? And the antivirus industry at that stage was a bunch of dinosaurs waiting to be eaten by something like CrowdStrike happening later. And
that's a very fair assessment, and that's obviously what exactly happened, right? Although the dinosaurs are still, with all deferences to our current sponsors who are this is going to be streamed out on. So
So we were very unsuccessful in selling this to the antivirus industry. But we were quite successful in selling this to various governments that were using it to track, is this team China, is this team Russia, and so forth. Then we got super
intelligence kind of evolved out of that and kind of probably saved the company in many ways. Is that?
Yeah. And I mean, we got very, very lucky then that the Chinese government ended up hacking Google at just the right point in time. And then Google decided they need some tooling and expertise that they currently don't have. And then that led to us getting acquired by Google in 2011 and then integrated into Google. That was a happy ending to what was probably the most ill-conceived business plan ever.
But I think it led to the weird state now where you've got those tools and they were a little bit orphaned, but that kind of let them flourish in a way. I would that be a fair statement?
So I'm still waiting for BinDiff to become fully open source, and I'm hoping that Google will eventually do that. But it's
Please,
a big organization.
Yeah.
Yes.
So tell me, so that led you to a very, I guess, prolific or very Google Project Zero. You did then you moved over to there, and you did a lot of cool stuff during your tenure there. Tell us a little bit about that and the whole environment there.
Yeah, so after joining Google, I found myself in a situation where we were mostly doing work on the defensive side out of a sudden, meaning work related to malware analysis, threat intelligence, and so forth. And I get a little bit unhappy if I do too much of that. And then I got lucky in the sense that a couple of years into my tenure at Google, the entire Rowhammer thing happened. And there was this paper that had described Rowhammer as a phenomenon, and there was a discussion inside Google.
That's fair. Yeah. It really was. It was another one of these quantum steps. It was you could hear the light bulb going on over everybody's head around the world when it kind of dropped. So
yeah. So the paper itself that described Rowhammer as a phenomenon. There was a lot of discussion within Google at the time whether this is paperware or whether this is real, right? Because they had to instrument the DRAM, they had to use an FPGA to talk to the DRAM fast enough, and it was very, very unclear whether we could ever trigger this in software. And then my colleague, Mark Seaborn, another Googler that was working on one of the sandboxing mechanisms, I think for NACL at the time, he managed to reproduce this on Flippy the laptop. We call him Flippy the laptop because it was really patient zero. It was the ThinkPad with the worst RAM ever. But it was also the ThinkPad where we could reliably reproduce the effect. And then once you've got the patient zero, you finally have something where you can start experimenting and working with. And then the backstory to this is that I had, in the years before Rowhammer, gotten enamored, like probably starting in 2007 or 8, I'd gotten enamored with really shitty bugs. What this means concretely is, I moved to do some client-side exploitation work in, I think, 2007-ish, doing some Adobe Reader stuff at the time. And I also, because I was running
target-rich environments.
Because I was running a company at the same time, I was severely time constrained. So the time I could spend on actually auditing got less and less. And then I had never been a big fan of fuzz testing, even though I had begrudgingly accepted that it's effective. And then people, like a friend of mine just said, hey, you don't have time for this, so I'll just do fuzz testing of Adobe. And then I got a whole bunch of super bizarre crashes. And normally my approach to dealing with these crashes is try to do a root cause analysis of the underlying bug and then figure out what the bug is and then go from there in a very carefully analyzed exploitation attempt.
Look for the classes of bugs and then look for it in other spots kind of thing.
Also, my philosophy had always been understand the bug that you're exploiting in detail and in depth. And then only if you understand the bug that you're exploiting in detail and in depth, move on to the exploitation phase. And I taught that in my exploitation classes, and I was absolutely convinced that it's always the right way to go. And then I found myself with a bunch of really, really shitty crashes in Adobe where I failed to root cause the underlying bug properly. And I really never, like to this day, I don't precisely know what the underlying bug was. And I realized that I can fill memory with JavaScript SpiderMonkey bytecode sufficiently heavily that even if I can just randomly, like one of the bugs, I couldn't root cause, and it manifested itself that I could write a byte of my choosing randomly into like a 6 megabyte area of memory. And then I was like, okay, if I can't root cause this, what can I do to actually turn this really shitty bug where I get to randomly write a particular byte value? How can I make this useful? And the trick I came up with is you fill that piece of memory with JavaScript bytecode, because Adobe Reader at the time had integrated SpiderMonkey, which is the JavaScript engine from Firefox. So interestingly, the JavaScript bytecode itself is much more powerful than JavaScript itself, right? Once you can execute JavaScript bytecode, it's essentially the same as executing real code. And now the beauty of the bytecode, though, is there's no write protection to it. Like you can just corrupt the bytecode. So the trick was then to write a JavaScript bytecode, jump into a whole bunch of JavaScript bytecode you'd spammed onto the heap, and then to get control through that. So you would alternate data you control with JavaScript bytecode, and then instead of hijacking the instruction pointer, you would hijack the virtual instruction pointer of that like the bytecode interpreter.
Kind of a spray and pray.
But a spray and pray where you even avoid jumping anywhere with the real instruction pointer. So you're, and from that experience, that experience changed my view towards seemingly unexploitable bugs a little bit, and it helped me clarify some of my thoughts around weird machine programming. And I gave a talk in 2011, right after being acquired by Google at Infiltrate, that I'm reasonably proud of to this day, because I talk a little bit about my shift in perspective there.
I remembered, actually.
So that shift in perspective, like whenever you have something that, if you squint enough, looks like an interpreter, and that really means any loop that iterates over a string and then decides what to do. So a lot of parsers and interpreters actually look very similar. So whenever you've got something like this, you can do funny stuff with it. And from that experience, I then started thinking more and more about what's the shittiest possible bug you can exploit. And a couple of years before Rowhammer, a friend of mine and me had run, like when we were already at Google, we'd run a back of the envelope calculation over lunch, where if I can run JavaScript ads or Flash ads on a certain number of machines by paying for it, like I can just ask an advertising provider to make sure this thing runs on 5 million machines, at which point will I get a compromise just from random bit flips in RAM on shitty laptops. So we'd run those numbers beforehand, like what's the cost of getting a random compromise somewhere on the internet by just paying for ads? So when Rowhammer happened, a lot of the thoughts about what's the right strategy to do exploitation of random bit flips in memory had already been discussed over lunch to some extent. And then Mark Seaborn brought an actual real-world laptop that did this, and then also did almost all of the heavy lifting on the actual exploitation. So my contribution was relatively minor to the entire thing. I contributed some ideas about spraying page table entries into physical memory. And I contributed an idea for doing something called double-sided row hammering. So instead of hammering from one side, you alternate to two sides, and you get better bit flips. So the reality is, I'm getting more credit for Rowhammer than I'm really I really deserve, because Mark Seaborn did all of the clever work.
It's a good story. I'll remember Flippy the laptop for all hail Flippy.
Flippy was also interesting because we could see the physical deterioration of the RAM over time. Over the course of our experiments, Flippy got worse, and that's a really interesting thing that people don't talk about enough with regards to Rowhammer. That you actually have physical deterioration of DRAM if you hammer long enough.
That's really interesting, because I've never actually ever heard anyone talk about that before. Now I'm just my mind again. We're not done with Rowhammer. I don't think we're done, and I'll ask you more about this in the future, because it's a long path there, right?
Yeah. And Rowhammer was super interesting for me on a philosophical level as well, because it made me grow a lot as a computer scientist, because it made me understand that the determinism we see in computing is an illusion. Generations of electrical engineers died a painful death in order to give us the illusion of determinism and monocausality in computing, when in reality your computing equipment is only stochastically deterministic, meaning it's deterministic most of the time unless something bad happens. And and that was a big thing to learn.
Yeah. So I was actually hitting. I was trying to hit my yes button, but it wasn't working right. So so let's talk a little bit. Yeah, we're good on time still. Let's talk a little bit about the future of that. Let's kind of change gears, and before we get off that, tell me a little bit about. I mean, Google is such a famously insular organization, but Google Zero, and I'm about to talk to Natalie Silvanovich a little bit later today, and the Google Zero itself was is still currently such a hothouse of brilliance right there. Just fascinating. Tell me a little bit about how the dynamics, the stories, what your recollections are of that, because Google, speaking of things that move the needle, Google Zero, Project Zero, has been phenomenal, right? Yeah. We all say thank you, Google, for all your help for the entire world in that area. So tell me a few stories, Uncle Halvar.
Yeah. I mean, P0 is a fascinating thing in many ways, right? It's very improbable that it exists in the first place, and Chris Evans pulled off a major magic trick by even willing it into existence. Because of its strange history, it's also attached to a somewhat illogical branch of the Google org structure, because it wasn't part of Google infrastructure security. It's a part of the Chrome organization historically. But then it's also a fascinating group of people. It's one of the nicest teams I've ever worked in, because everybody's so competent that they don't have to be mean. In a lot of organizations,
they don't have to. Yes, it's quiet confidence, and I notice it all the time in our conference speakers. That the folks who know their stuff usually aren't assertive, and whether they're some of the best listeners that I know of, yourself included, sir. So go on.
Oh, thank you. Sorry, so P0 was an interesting experience for me also, because I hadn't done a lot of offensive work in a couple of years. It was very helpful to I don't think I had great output during my tenure in P0. I objectively didn't. It was very useful for me to get back to the metal in terms of over time, there's a lot of demands on you to do more management, to do more organizational stuff, to do all sorts of things except the actual work.
Growing up, yeah.
And P0 was very helpful in allowing me to get back to the actual meat of things. And I did waste a little bit of time because of my insane preference for really shitty bugs. So I've got this hypothesis that a mediocre chef can make a great meal out of great ingredients, but a great chef makes a good meal out of really shitty ingredients, right? And
I like that analogy. That's good.
And I have a dangerous fascination with terrible bugs in the sense that I will try to write an exploit for the worst bug ever when it would be much more time efficient to just find a better bug.
It can be time shit. But the power of that, nobody thought this was exploitable, and oh my god, if you do this triple backflip here, you can get it. That's still, it's a good reminder for everybody, because we all tend to be dismissive of a lot of bugs. Oh, hey, this is mitigated by this, but we don't, or the broken patch. I mean,
it's also something that you need to be able to afford. Like if you're in a position where you paid for wounds, it's much easier to just repeat a game than to spend 6 months on a potentially. I mean, if your profession is turning around bugs quickly, you probably want to audit for bugs that you can exploit in the first place. Whereas if you just love bugs, then you can audit for the most bizarre, crappy thing possible,
and then spend a month not getting anywhere. Right? Exactly. It's a labor of love in so many ways.
And there's an exploitation trade-off, right? Where like the thing that is most profitable when you need to turn around bugs isn't necessarily what teaches you most. And I've always erred on the side of do what teaches me most. So
I resemble that remark. So have you recanted on fuzzers fully these days? I mean,
you can't argue with the effectiveness of them. There's another argument to be made that of all the methods we have to do code analysis, fuzzers are the only ones for which we have dedicated hardware. Right? So people always talk about smart fuzzing and so forth, but you have to remember that the CPU is made to execute instructions really quickly. So as soon as you try to be smart about fuzzing or about anything, if you try to do abstract interpretation, anything you do, you start out with about 1 million x slowdown for not just running the code. So anything you do is going to be 1 million x less effective than just running the code, and you have to recover from that. And the reality is that's very rare for anything sophisticated to be able to catch up to a 1 million x slowdown. And I think AFL was such a success because it was designed to retain as much efficiency as possible. Like people were trying to do coverage-based fuzzing before, but they did it with breakpoints and a context switch and data structures.
Expensive, heavy methods. This AFL was just so fast and cheap, right?
Yeah. So. And that's something to always keep in mind with anything that you do for bug discovery. Compared to a stupid fuzzer, you're always going to be a million times slower. And you need to figure out, and then being faster wins.
We're doomed to be defeated by a swarm of stupid robots, I guess.
Well, I think we also, like, if you look at something like AlphaGo and also the chess, what was called Alpha, well, the Deep Blue or whatever it was. Yeah. So whenever we talk about AI, everybody underestimates the role that just sheer computational force plays in everything AI related. And you can argue that if it was calorie consumption per calorie consumption, that humanity is still far ahead of any computer Lee Sedol runs on a bowl of porridge, and AlphaGo does not run on a bowl of porridge. So, but I guess what I'm saying is people dismiss brute force and just throwing mass amounts of compute at problems. But the reality is that a lot of what we deem AI is brute force.
it's not real intelligence at this point, but it's just sheer raw horsepower. And I think we're still discovering what the boundaries of that are, in my opinion.
I think the estimate is that the human brain has, 86 billion neurons? Yeah, 86 billion neurons is a lot of neurons.
Yeah, it is. And they work in analog states as opposed to full binary. So there's even more, those 86 millions kind of billion are exponentially. Yeah. 86 billion. Yeah. We're getting off into the weeds.
Yeah.
We're trying. I asked you if you have advice for sort of new folks starting out in this area of how to approach one thing that's always fascinates me about you is I love the way your brain works. You have a very intricate way and a very clear way of explaining things. So I gave you a little bit of heads up. What kind of advice do you have for people who are just beginning their careers and starting to look at this area in terms of approaches to bug hunting? And this discussion that we've just had about fuzzers, anything that you want to say to folks along those lines?
It's a very complicated question. First of all,
it is.
The first thing I need to say is don't believe a lot of advice from people like me, because we have a sample of one. Like the experience that people like Mark Dowd and me, or whoever else went through, all of us have a sample of precisely one trajectory and one history. And a lot of us were of the opinion that all vulnerabilities are going to be gone in 5 years, and had that opinion for 20 years. And so it's not clear to me whether my advice is actually going to be very valuable going forward. So that's the first big caveat. The second thing is, when it comes to vulnerability hunting and exploitation and so forth, one of the things I've observed is that the most difficult thing about it is often managing your own psychology, because it is it's a process that is deeply frustrating at times, and that oscillates between deep depression and great exhilaration when something works.
Roller coaster.
And this, it's definitely a roller coaster. There's a sawtooth pattern of your motivation curve. Oh, this could be a bug. This could be a bug, and no, it's not a bug. And managing those lows is very difficult. And then there's a dangerous component to this, because there's many experiments with rats, like about random intermittent payoffs. So if you give a rat a lever, and every time it pushes the lever, it gets a treat, it'll push the lever whenever it wants a treat. But if you make the payout random, so only a certain fraction of the time the rat will get a treat when it pushes the lever, it'll start pushing the lever all the damn time.
Mm-hmm.
And so the randomness of a payout makes things addictive. And there is an aspect to vulnerability research that can be addictive, where people get addicted to that rush of stuff working. And a professor of mine, when I studied mathematics, joked that the joy in mathematics is often the receding of the pain. And the same can be the case for vulnerdev, where you work on a problem, you don't make progress, it's frustrating, yada yada yada, and then it works, and it's absolute magic, and it's the closest thing to magic that you'll see in this world.
It's a gambling addiction, but you're gambling with your time.
Yeah, and managing your psychology around that is difficult. And I've seen people manage it in different manners, and managing your own well-being while doing successful vulnerability research is not easy for anybody, particularly not for me, but for many other people, it's also difficult. So my advice to people getting into this would be very aware of the addictive nature of this. Be very aware of the impact on your psychology that this sort of work has, and start working early on finding balance and finding ways of being sustainable while doing this, because everything in life is a marathon. Like your professional career is going to be 45 years, most likely plus. So you need to be able to do those 45 years without burning out or having mental health issues or having other forms of breakdown. And it isn't easy for anybody. So just make sure you take care of yourself, take breaks, go for a walk.
Speaking as an old fart here as well, that was some of the most brilliant computer security advice I've ever heard, because I'll just reiterate exactly what you said. That's exactly what people should be thinking about. You've got to keep that pace. I've seen so many people burn out. So I talked to a lot of folks as speakers at the conferences, and it meant that balancing that life balance is huge. Thanks for reminding us of that as well. I'm going to switch back a little bit to kind of, we have a few more minutes. Give us one things this is the question I've really been looking forward to, is because I'm very curious to see what your insight is. Where's this stuff heading to? What's the vulnerabilities have been mutating and shifting. We've seen the changes to fuzzers over the last decades. And so where, Give us a little bit of a crystal ball gaze as to where you think that we need to focus attention on, and where attention's going to go to.
Yeah. So, I mean, the biggest trend in computing right now is the trend to heterogeneous compute, right? Meaning we see all these big little core designs in CPUs. We see much more task-specific hardware, and all of this is triggered by the slowdown in Moore's law. So if you look at a modern CPU, you've got different cores. You've got different cache hierarchies, you've got hardware-based JPEG decoders, hardware-based, like you've got the GPU, you've got hardware-based AI accelerators. So
tensor engines in the new Pixel 6, etc., all that kind of stuff. It's getting more baroque. It's starting to look like an IBM 360 again, right?
Yeah, and I mean the CPU model, like we're all still teaching as if we just have a very, very fast PDP-11. And but the computational model is no longer true, right? We have all these specialized pieces of hardware that get work from the rest of the system and then do stuff. And that's a huge attack surface that is quite under-researched. And given that it's mostly done by electrical engineers, you'll find a lot of silly, like I saw the spec for a hardware JPEG decoder that you sent a JPEG to, and it would decode the image into a memory area. But the hardware did not foresee passing a parameter specifying the size of the output. Right. So you just read the spec. Yeah, you just read the spec, and you're like, okay, this is going to be borked somewhere. So
you can see the mushroom cloud already, right?
Yeah, so given that we're seeing more and more task-specific hardware, we're also going to see more vulnerabilities in interaction with that task-specific hardware. We then have much more complicated, relaxed memory models. Like if you look at ARM and the absence of strict ordering of stores versus x86, you've got code that'll work fine on x86 that'll be broken on ARM. So I think the interaction between software and the task-specific hardware is an underexplored attack surface. It goes all the way to GPUs and the tensor engines and whatnot.
CPUs in your NIC. It's all over the place. There's a whole area of firmware and firmware within firmware, and I think I strongly agree with that for a forecast.
Yeah, and I mean every device is now a network of computers, and there's a lot of work. I mean,
down to even your watch, right? Yeah. How many CPUs are in an Apple watch, right?
Yeah, and then and another interesting question is, well, we're not done with Rowhammer because things are still shrinking, and we'll see more effects from shrinkage. For devices that you hold in your hand, there's also the question of what can you do in order to induce faults, like electromagnetic fault injection, whatnot. Like as soon as you've got physical access to a device, you've got all like a billion mechanisms to take them out of spec. Like for local access, a billion mechanisms to take them out of spec is one thing that's underappreciated. For other devices, the interaction with the custom hardware or the custom specific circuitry now for task-specific workloads is super interesting. And I think those two things will be fruitful. Then security as a whole is changing in the sense that the backend infrastructure these days does not look like the backend infrastructure 10 years ago. Like everything is now very similar to what Google looked like. You've got at Google you had Borg, and now everybody runs Kubernetes. And in some sense, what we're doing there is we're building what I call the operating system, or the missing operating system, like the operating system that treats an entire data center like one computer. And we don't really have a good security model for that operating system because nobody has time to think about it, right? So I expect that every privilege delegation bug that Forshaw has found in Windows is being recreated at scale inside every major SaaS provider now, as they have all these services in a big cluster talking to each other that are all confused about who's allowed to do what. So on the server side, there's a lot of really interesting work to be done there. In some sense, the old fart in me is a little bit sad because Vuln these days is extremely focused on end-user devices and client sides. And the reason for this is actually partially legal and economical, because
we don't get to play with the clouds, right? That's the part of it too.
We don't get to pay to play with it, but also customers are like the governments that are buying all the vulnerabilities usually only have the legal mandate to go after
the
device, right? And
the tail wagging the horse kind of the thing,
So for an old school hacker that loved the server side infrastructure compromise,
that's the real hardware.
That's where you want to be, right? So I think going after all these cloud infrastructures is something that is super interesting and underappreciated. I'm not sure whether it's the best place to earn money, but certainly the best place for finding funny things. Like on the defensive side, if you get to do cloud security consulting, you probably can earn yourself a golden Lamborghini in the next couple of years. But if you want to do offensive work, I think the server side is interesting but not lucrative.
That's a fair statement, I think. I agree with that. So we got about 5 or 10 minutes left here, maximum. So let me just jump in. Tell me, this is I've been promising you and saying, give us a plug for what you're doing now. Tell us about your new effort. I'm fascinated to hear, actually.
So the new effort
whatever you can tell us.
Yeah. So the new effort is already over in some sense already. Well, over and at the beginning. So what I realized at some point is that the skill set you pick up in security is applicable in other areas in computing. And looking at the end of Moore's Law, I realized that a lot of the work, like a lot of the skills I had from security work, translate really nicely to performance work. Like a lot of the performance work is very, very similar. Like it's questions of heap layout, it's questions of cache locality, it's a lot of low-level stuff, but it also has this full spectrum computer science where you go from the very abstract to the very low level. And it turns out that when you do performance work, you can do something that isn't part of human conflict. So one of the things that burned me out on security is always about human conflict. It's always you're either hacking or securing something for somebody against somebody. And Bob Morris Sr. asked me one day when I first met him, I told him I study mathematics, and he asked, for whom? And that was a very confusing statement or question at the time because I was just going to university. But this for whom question is actually a core question of working in security, because whoever you work for, you need to ask, for whom are you working? And I ran out of parties I wanted to work for. So the nice thing about performance is you're not taking sides in human conflict. You're really just making something run faster and more energy efficient, and it's cheaper and emits less CO2 thereafter, so everybody's happy. And in order to facilitate this, we built something called Profiler. Profiler is the profiler you need for data center-wide profiling. I mentioned the missing operating system. So if you look at a data center as one computer, you need an operating system and you need development tools. And clearly one development tool you want is a profiler that just measures where are all my cycles going across my entire data center. And we built that. Profiler is an agent you install on a couple 10,000 machines, and it'll measure 40 times per second where is CPU time going, and it'll do stack unwinding using eBPF from the Linux kernel for all sorts of runtimes. and you get a nice web interface where you can tell, okay, these lines of code are eating this many CPUs, and then you can start optimizing and just saving tons of CPU cycles, energy, and money.
And time optimizing too, obviously.
Oh,
right?
Yeah. And it's super interesting. Also, the work on it was very similar to security work. Like, it involved some reverse engineering. It involved dealing with weird compiler formats. It then involved a lot of constrained programming within eBPF, because eBPF is a bit of a constrained environment. And then you end up finding bugs everywhere, except that these bugs are performance bugs, not security bugs.
Mm-hmm.
And yeah, so that's what we've been up to. And then we launched the product in August. And a week ago or so, there was an announcement that we've been acquired by Elastic. So the data center-wide profiling that we've been building is now going to become part of the Elastic observability stack. And the idea here is that you can then correlate the profiling data you're gathering with other sources of data like logs, metrics, and so forth. And so we expect to do the same, like similar work to what we've been doing, just more of it.
Sounds super cool, actually. Interesting, and congratulations on the Elastic purchase. That's another adventure is integrating into that whole environment, and we'll stay off the subject of AWS politics. And you know, that alarm means that I have to go and prepare lunch for my kids, and so I have to say thank you very much for your wisdom. Really, as you've said a couple of things that really opened my eyes, and it's as always lovely to see you, my friend. So we'll just get our end here.